Saxon Algebra 1, Lesson 13. Lucky number 13. We're going to talk about order of operations some more. Basically, we're doing more of what we've been doing, multiplying sign numbers, symbols of inclusion. It's all familiar. We're just making it a little bit trickier. I know, right? Lucky you. Okay, let's review the order of operations. First, we do any work inside symbols of inclusion, right? That's the fancy name for those. We do work inside of those first. Then we do any roots or exponents. We haven't really touched on this yet. We'll get to that later. Then we multiply and divide. Remember that this x means there's a number in there. This x stands for multiplication. It's a little confusing because I'm using x for two different things, but hang with me. And then we add and subtract less. That is our order of operations. And we'll keep this in mind as we do the problems. All right, let's look at the first one. Are you ready? I know I am. 13.1. Turn my page. Our instructions are to simplify. Simplify, okay. And I have to tell you, these problems are long, and it's fairly important that we copy them as they're written in the book. As we get more proficient at these, I'll give you some shortcuts. Wait, I'm combining two different problems. Let me start over. This part we want, but this part was from the next problem. I made that up. We'll get to that. Okay. Pay no attention to that. This is our problem. What we notice is that there are rounded parentheses, and then there are squared off brackets, we often call those, and then there are the pointy kind too. This one looks better. This one's a little squishy. But there are these pointy kind of parentheses too. We have three different kinds of symbols of inclusion. How the heck are we supposed to deal with that? Well, what we want to try to do is go inside to the very center of the problem. So we think of these as like walls or shells that protect the problem. We want to go all the way to the inside, and what we see is that this is at the very middle of the problem, right? The work inside of these two parentheses is multiplied times each other. So technically we could do it even like this, right? So the first thing we want to do is the work inside of these parentheses. This all stays the same. Minus 3 minus 2, that's on the ladder in the meadow, that's minus 5. Minus 7 plus 4, that is negative 3. And then we copy the rest of the problem. Okay, so we've done that much of the work so far. Now we're ready to come back a little bit. The work inside of these has been done, but now we can actually multiply it together, right? And then our last step will be looking at that whole square brackety thing. Well, that's not the very last. Then we have one more to go after that, right? We'll want to multiply by the 5 and deal with the outermost one. So we're going step by step from the middle of the problem out. Okay, so the next step is what we'll do in pink. 4 times 2. This becomes 5 times 3 is 15. Minus and a minus go together to make a plus. Okay, now the next step, we've done the pink step, so now we're on the green step. This step is tricky Because we see multiply by 2 and subtract 5. Well, we say, okay, we multiply first before we subtract 5. But if we look carefully, we see that's not quite right, because the minus 5 is within the square brackets, but the multiply by 2 is outside of the square brackets. So we do the minus 5 first. Do you see that? This is where the square brackets are. These problems are really tricky, so you have to look carefully and keep track of the different shaped brackets and which is outside of what. So this all stays the same, and now our whole square bracket thing is plus 15 minus 5. Okay, that's plus 10. I don't need the plus sign, but I like it because it helps me stay really clear on what's happening. Parentheses. Okay, and now again, let me just highlight in blue so you can see this. Now we're ready to do everything in the pointy parentheses. Now we're ready to take on that times 2. So again, as you're doing these problems, make sure you're paying very careful attention to which numbers are inside which sets of brackets so that you will keep the steps straight and not just start going by order of operations. My words don't make sense. I hope you understand what I mean. Okay, so now it's 4, and now we're doing the whole pointy parentheses. 2 times 10 is 20. 4, oh, I see what I did. Okay, so all of this becomes 80, right? What I forgot to copy was that there's a minus 2. That is outside all of the brackets and parentheses. So it's like that. So 4 times 20 is 80. Now we're ready to take on that minus 2. And our final answer is 78. Make sense? That little minus 2 at the end, that was easy. The hardest part is keeping track of where exactly we are as we go to the middle of these and slowly work our way out. Let's try another one. Example 13.2. This problem has a new twist. Oh, this is the pointy kind. Looks like a chicken beak now, doesn't it? What? Okay, I'm just double checking to make sure I got this right. Okay, here's the other chicken beak out here. All right, simplify is our instruction again. And we see that this is actually a division problem. Remember that a fraction line always says divided by. So this is a fraction. This is a division problem. And the way we're going to do it is we're going to simplify the top, simplify the bottom, put the two pieces together, and see if we can simplify the fraction that we make. So as we do this, we'll deal with first the numerator, get that all down to a number, then we'll do the denominator. Now, I want you to take a look at what we have going on here. We have pointies, and then square, and then rounded square. Notice that here, these rounded and then the squared, they don't do anything. They're just like two layers on top of each other. Do you see what I mean? There's no other numbers that are outside the rounded but inside the squared. So those are what I would call redundant parentheses. And then notice this one doesn't have any work to do inside of it. All right, so this is just the numerator that I'm working on now. It will be minus 3 times, oh, that's the pointy one. And then I'm just going to drop these middle parentheses. Minus 2 minus 3 is minus 5. And then that's times minus 2. And then we have another pointy one out there. Pretend that's a pointy one. It's kind of weird. All right, does that make sense? This one, there's no work to do. This one we had work to do, but we had a double set of symbols of inclusion that we didn't need. That was redundant. So now we're ready to, we're still working within these guys, so we'll do this before we do anything outside of it. So this becomes minus 3, 5 times 2 is 10, minus and a minus make a plus, right? And that means that our final answer here, minus 3 times positive 10, is minus 30, right? Now, that's not the answer to our problem, but that's the answer to our numerator. So I like to squiggle that, which helps me, I'm going to adjust my light just a little. It helps me remember that that's a really important number and I don't want to lose track of it, but I don't need it right now. Now we'll do the denominator. All right, I'll use a different color for that. I like using all the different colors. It's really fun. First, we'll do what's inside the parentheses. And then we'll get minus 3 times 4 minus 2 is 2, right? So that equals negative 6. And again, that's not our final answer, but we need that. Now, for the last step of the problem, I put my numerator over my denominator and I simplify. And my final answer is 5, and that's correct. All right, so that's how you approach these problems that are fractions, which remember, that just means they're division. This is mathematicians' favorite way to show division in algebra. We don't use this little sign very often, okay? So there's example 13.2. Let's carry on. Example 13.3 is a long string of numbers. There are letter parts to it. And it's got 5 different numbers that we're multiplying together. And we'll review the rules for this. Oh no, that's not a minus sign, that's just pretend it's nothing. Okay, John is showing us that we have a multiplication problem here. He's using parentheses to indicate multiplication, and we know that because there's no work to do inside of the parentheses, right? It's already just a single number and its sign. So that tells us, okay, we don't have to worry about order of operations. We're just going to multiply this whole monster together. Now, the first step to do this, we simply multiply the numbers. We ignore the signs. Uh-oh, my marker is giving out. Okay, so let's multiply these numbers. We can look for easy combinations. Now, one thing I notice is for some of these numbers, we have plus signs. This number doesn't have anything written by it. It's still positive. It doesn't matter if it's plain or if it's got the plus sign. We know it's positive, okay? But we're not worrying about the signs anyway. I just wanted to point that out to you. We're not worrying about the signs yet. All right, what I do is I look for things that are easy. 2 times 5, that's 10. And I'm going to go ahead and write positive 10 because I want to make sure I keep track of that. 4 times 3, oh wait, we're not talking about signs yet. We're just talking about numbers. 4 times 3 is 12. So this much I know is 120, right? Times 6. So I'll just put that underneath. 0, 12. Okay? This is the number that we get when we multiply all of these guys in a row, right? Notice that I did not just start here and go down the line. I bundled the numbers into interesting pairs that were easy for me to figure out. Step 2, count the minus signs, not the positive signs. Count only the minus signs. If you end up with an odd number of signs, that means that your answer is negative. If you come up with an even number of minus signs, then your number is positive. Okay, so in our case, we see there are 1, 2 negative signs. Okay, that's an even number. 2 is an even number. So that means our answer here is 720. And let me make sure that's right. Hang on, just flipping to make sure I have that answer right. Oh, I see what's happening here. John doesn't even care if we actually do the multiplication. He just wants to know if that answer is positive or negative, and we said positive, and that's right. Okay? So these problems are simpler. I was making it too hard. C, D, E. This is the last of the problems for this lesson. Let me show you how they work, though, because I think you have some in your you have some in your practice. What he wants us to do, notice he gives us these strings of numbers, and I went ahead and multiplied that. I didn't need to. You guys, I was making it harder than it needed to be. I'm sorry. What we want to do is simply use the rules that I just showed you. We count up the minus signs. If we have an odd number, it's negative. If we have an even number, it's positive. And John just wants us to tell us, is it negative or positive? And you can just use the sign too. You don't have to write the word up. All right, so let's look at these. B, let's count the negative signs. Not any, 0. 0 is considered an even number. So B is positive. That's all you have to do for your homework, all right? C, okay, 1, 2, 3 negative signs. Remember, we don't care if there's a plus sign or if it's just the plain number. We're only counting negatives. 1, 2, 3, that's an odd number, so 3 is negative. D, 1, 2, 3, 4, 5 negative signs. 5 is an odd number, so that one must be negative. And E, 1, 2, 3, 4. There's a plus sign in there, though. There is a plus sign in there. So we don't know. Once we throw in a plus or minus and create 2 separate terms, that changes the rules. The rules only work, that add them up, and if it's positive or negative, that rule only works if we're not doing any adding and subtracting, if it's just plain multiplication. So for this one, we don't know if the answer is going to be positive or negative. And John goes ahead and works it out to find the answer. It turns out that it is negative, but our rule doesn't work on this one, and that's the answer I want you to do. I don't care for you to do this. I just want you to say, rule does not apply. Okay, and it's that plus sign. Notice that this plus sign is not like that plus sign. That plus sign is attached to the 5, and it's part of the string of multiplication. This plus sign is just chilling by himself and causing drama in the hood, right? So watch out for that. Watch out for those breaks in the series of multiplication that will mess us up. And again, a rule does not apply unless it's all multiplication. All right, for your practice, look, there's a long symbols of inclusion. Here's a division one. Remember, just do the top, do the bottom, put them together at the end. This is where we practice our rule of counting up the minuses. And then here's one like we were just doing. You don't have to multiply it. Just give the reason why this is positive or negative. And all you have to do is count up the minus signs and say, 8 minus signs or whatever. 1, 2, 3, 4, 5, 6, 7. I see 7 minus signs, so you'll have to figure out what that means. But what I was checking to see is there's no tricks in there. There's no added plus or minus in between the multiplication that break up the terms. All right, that is lesson 13. This is great practice. I know we did all this last year, but this is really great just to get your brain remembering all these rules and the exceptions to the rules and keep you on the straight and narrow. Where's my checklist? Here it is. Remember to get your, if you're working with me and we're using a checklist, remember to have your parents sign this when we do our video chats at the end of the week. I don't care about having this week signed because you still have the weekend to work on this. So this one doesn't have to be done. I'll be looking at last week's lesson and making sure that your parents signed off on that one. That's the one I'm worried about. All right. Yay, we're done. Goodbye.